Hello everyone, Waves Introduction. In this video, I'll be giving a general introduction about the concept of waves. We can see ripples on the surface of a pond or a lake if we throw a pebble into it. The ripples are an example of a mechanical wave. The pebble which is touching the water creates a disturbance which is propagated to other parts of the water surface. And this propagation of the disturbance is what we see as ripples. In the case of waves, there is no actual movement of matter. Only the disturbance is propagated. This fact can be seen by using some cork strips. If we put some cork strips in the water and if we create ripples, we can see that the cork strips will begin to move up and down and it won't get displaced in the direction of propagation. So we can say that waves are disturbances which propagate through time and space without the actual physical transfer or flow of matter as a whole. That is, only the disturbances propagate. Examples of waves are sound waves, light waves, etc. We can say that there are mainly three types of waves. They are the mechanical waves that we usually observe in nature, like the waves that were produced when we threw the pebble into the pond, requires a medium for propagation. Sound waves are also mechanical waves. Sound can only be propagated if there is a medium. In vacuum, sound waves cannot propagate. But in the case of electromagnetic waves, it does not require a medium for its propagation. Examples of electromagnetic waves include radio waves, light waves, etc. Then the third one is the matter waves. These are the waves produced by the motion of the fundamental particles of matter like electrons, protons, or neutrons. Now, some of the famous scientists associated with physics of wave motion are Christian Huygens, Robert Hooke, and Isaac Newton. Mainly what we shall be seeing in this chapter of the NCERT textbook is mechanical waves. And mechanical waves obey the Newton's laws of motion. Now, there are two types of mechanical waves based on the relationship between the direction of propagation and the direction of disturbance. First one is the transverse waves. In this case, the direction of propagation and the direction of disturbance are perpendicular to each other. Whereas the transverse waves are those in which direction of display or displacement in the medium is perpendicular to that of the propagation of the wave. Let us consider an example in which a long string is attached to wall at one end and the other end is held tightly by a person. Now the person moves the end of the string up and down to create a sinusoidal wave which propagates through the string. It can be observed that the sinusoidal wave, which is the transverse wave, will be as shown in this figure. In this transverse wave, the maximum point is known as the crest and the minimum point is known as the trough. And wavelength is the distance between two consecutive crests or troughs. Now we shall see the longitudinal wave. In this case, the propagation and the disturbance are parallel to each other. Longitudinal waves consist of rarefactions and compression. Longitudinal means something related to length. In longitudinal waves, direction of disturbance or displacement in the medium is along the propagation of the wave. Constituents of the medium oscillate parallel to the direction of wave propagation. Now, in the case of a transverse wave, the particle motion is normal to the direction of propagation of the wave. Therefore, as the wave propagates, each element of the medium undergoes a shearing strain. Transverse waves can therefore be propagated only in those media which can sustain shearing stress, such as solids and strings, and not in fluids. Fluids as well as solids can sustain compressive strain. Therefore, longitudinal waves can propagate in all elastic media. The way in which sound propagates in air is in the form of longitudinal waves. So this is the end of this video. In this video, I have just given a brief introduction to the topic waves. If you have got any doubt in any of the topics discussed in this video, please comment in the section below. Thank you.